Assalamualaikum warahmatullahi wabarakatuh. Today, me and my group will be explaining Lab 4, Discrete Fourier Transform. Our group consists of 3 persons, which is Muhammad Syahir, me, AMIRA, and NURULAIN. Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Syahir, and I will be explaining the coding for part 1 and part 2. Firstly, the n is defined as 10, and the small n is also defined. Then, the xn is defined as given in the lab sheet. Then, 4 functions were called, which are xdft1, xdft2, xdft3, and xdft4 for all the equations. Then, the magnitude of the DFTs were plotted, and the output was obtained. Next, for the second part, the inverse DFT of the above signal were obtained by using the equation shown in the video. Then the DFT signals were plotted. There are 7 in total, which can be seen in the result section. It's plotted by using the commands stated above. Then the DFT function was called, and n was defined before using loop to compute the DFT of the signal. Then n was defined again for the IDFT equation, and the loop function was did again to obtain the IDFT signal. Next, I would like to explain the simulation coding for part 2, which is matrix representation of the DFT. From line 1 to 4 is to clear coding and reset the command. Next, the user will need to input the value of x and value of n, which is sample size. Then, line 10 explained on how to obtain DFT using matrix of x. A was defined as DFT matrix, meanwhile 1 defined for length. Later, we equalize the size by simply multiply a and x value. The uppercase x will be defined as result output. We display the value of the x and set the magnitude of x is equal to the absolute value of the x. Start from line 23 to 33. We plot the graph for input signal to DFT matrix and magnitude spectrum of DFT using DFT matrix. For the second part, which is DFT of x using fast Fourier transform, x will be adjusted as FFT, the variable of x and capital N. For the third part, DFT of x using IDFT matrix, and B is set to the IDFT matrix. 2 graphs will be obtained, which is input signal and magnitude spectrum of IDFT matrix. For the fourth part, which is IDFT of x using inverse fast Fourier transform, the value of x is changed to IFFT with variable of x and capital N. Next, the C matrix will display the value of matrix A times B. For this part, we clarify the function for A and B, which is A or B times k plus 1, n plus 1 equals to exp in bracket negative 1j times 2 times pi times n times k over n. The value of B will be conjugate to get IDFT matrix of B. This is the output obtained from the coding. For input value of x, we will insert 1 and sample size of 10 for n. This result obtained for matrix A and 2 matrices for DFT matrix and FFT command. Then, the result of B obtained till column 10 and value of IDFT matrix and IFT command display as matrices 1 by 10. Meanwhile, C is the same form as A and B because only constant value will be displayed. Lastly, this is the figure obtained to represent the matrices value obtained.